Hey guys, here to go over our K2 study guide with you. So we're going to go through this hopefully relatively quickly. Hopefully you've attempted this on your own and it's just going through and checking your answers. For number 1, a plane flies for 3 hours directly east, and then turns southeast and flies for 1 hour. Draw out the component vectors for this situation. All right, so we're starting with 3 hours east. Make sure you label your vector. Make sure your vector has the arrowhead and the tail. And then southeast for 1 hour. And since it's just 1 hour, it should be a shorter vector. Number 2, a basketball player is running towards a basket and jumps in the air at an angle with the floor. Describe the path the player follows in the air and what angle gives him the most distance. All right, so think back to our activity on the computers the other day. All right, so we have our basketball player. So we have our nice little basket here. All right, so our basketball player has the ball. And we need to say what angle gives him the most distance and describe his path. So when we did the activity the other day, we learned that a 45-degree angle gives the most distance. So 45-degree angle from the floor is going to be similar there. Remember, it's a curved path, a parabola. So you need to make sure you understand that it's going to be a curved path. Parabola means ideally with the drawing that it is symmetrical, which means it's the same on both sides. A baseball is hit off the bat at an angle of 30 degrees and an initial speed of 50 meters per second. What do you know about its final speed? So again, when we have our angles and our projectiles, again, is a parabola, it's a curved parabola. So ideally, it should be the same on both sides. So if my ball is over here in my dotted lines, when I throw it at 50 meters per second, on the same spot over here, where it's caught, its final speed should also be 50 meters per second because it's symmetrical. All right, gravity affects the blank component of the velocity vector more than the blank component. So gravity affects our y component. So remember y, up and down, our vertical. So it affects our y component more than the x component. Label each point of the ball with both horizontal and vertical vectors correctly. All right, so I'm just going to do a couple of them throughout. Remember, our horizontal velocity is constant, so it should be approximately the same size all the way through. And our vertical component changes. So here, going to get a little bit smaller, a little bit smaller. Remember at the top of the curve, I'll go ahead and do this one too. Top of the curve, there is no y component because it's got to the top, it's kind of momentarily paused, and then it returns back down. So the arrow changes direction, and as we go, it should be getting longer because the acceleration is speeding the ball up. All right, how far did the apple fall if it was in free fall for 1.6 seconds? Remember, our words free fall indicate that we have an acceleration of 9.8 meters per second. We have a time here of 1.6 seconds. So again, always start with taking your notes. Always start taking notes. All right, let me slide the paper up. All right, so don't forget, we have our steps. First step is take notes. Second step is to figure out what formula we're going to use. So if you're still struggling with that, remember you do have your formula sheet. And we know that we're looking for, because it says how far, we're looking for a distance. All right, so on your formula sheet you see distance or displacement when our initial velocity is 0. Remember, we're talking about free fall. Before it drops, the initial velocity is 0. So our formula here is d equals 1/2 at squared. So our second step is to write down the formula. And then we substitute. Our third step is substitution. So D equals 0.5 times 9.8 times 1.6 squared. Point 0.5 times 9.8 times 1.6 squared. That's going to give me a 12.5 meters. So don't forget our units and circle the answer. All right, number 6. You drop an egg and it has a final velocity of 19.5 meters per second and is in free fall for 3.6 seconds. How far did the egg drop? All right, so we're going to start with our notes, taking what we know. We know our final velocity is 19.5 meters per second. We have a time of 3.6 seconds. Again, we have free fall here, so our acceleration is going to be 9.8. We want to know how far. That's what it's asking for, which is equivalent to distance. So this velocity here was actually an unneeded fact. All right, it wasn't necessary. So we don't have to do anything, but just leave it there in your notes. So our formula, again, D equals 1/2 AT squared. Then we're going to plug in and substitute. So 0.5 times 9.8 times 3.6 squared. 0.5 times 9.8 times 3.6 squared equals 63.5. So our distance equals 63.5 meters. Number 7, what is the final velocity of an egg drop package if it was in free fall for 1.3 seconds? All right, so again, we have free fall here. So I know my acceleration is going to be 9.8. I have a time of 1.3. It's asking for final velocity, so I know I'm looking for final velocity. And before we drop it, remember our initial velocity before we drop it equals 0. So my formula sheet, I'm looking for final velocity free fall when our initial velocity is 0. All right, so I have two formulas to choose from. All right, now I can look at them, see which variables I have. I wasn't given a distance, but I was given an acceleration, I was given a time. So I'm able to use this second formula. So VF equals VI plus A times T. Substitute. VF equals 0 plus 9.8 times 1.3. Nine 9.8 times 1.3 equals 12.74. Then it's velocity, so our unit is meters per second. All right, because we're given seconds here. All right, you're running at a velocity of 12 meters per second north when you throw a softball with a velocity compared to yourself of 22 meters per second north. What is the velocity of the ball compared to the ground? All right, so I'm already running. There's stick figure tearing running, and I have a ball. So I'm already going 12 meters per second. So which means the ball in my hand is also going 12 meters per second. Now I throw this ball at 22 meters per second. So from the ground, which remember is not moving, so from someone on the side, how fast does that ball, what's this velocity? How fast does it appear to be going? All right, so if I'm already going at 12 and I throw it at 22, that means I have to add them together. So 22 plus 12 equals 34 meters per second north. All right, number 9, using the graph below, add the component velocity vectors and draw your resultant vector. Assume each box on the graph to be 1 meter per second. All right, you can use a ruler, measure the resultant vector, or use a Pythagorean theorem to calculate the exact magnitude. All right, so I'm going to be going north, east, and south. So I want to make sure I have room in my grid for where I'm going to be at. So I'm going 5 north, 3, 4. I'm going to go ahead and start right here. All right, so here's my starting point. I'm going to go 5 north, 1, 2, 3, 4, 5. Draw my vector arrow. Don't forget to label, or you'll lose points. Now I need to go 3 east, 1, 2, 3. Remember, we always put the tail of the arrow at the arrowhead tip of the other. So this one was 3 meters per second east. Now I need to know let's go south. So 1, 2. And that one's 2 meters per second south. All right, so my resultant vector is going to be starting at the origination point, heading towards that. So it's going to be something like that. Now make sure when you draw your resultant vector, if you don't have another color to do it in, just do it as a dashed line. All right, so we need to find the resultant vector. So remember, when we have opposites, we have to subtract them. All right, we don't have anything else with east, so we know our one vector is going to be 3 meters per second east. But we have 5 meters per second north, and we have 2 meters per second south. So I subtract them. 5 minus 2 equals 3. Remember, it's going to take the direction of the larger number, so it's 3 meters per second north. So now that I have my 2 there, I can use the Pythagorean theorem. So C equals the square root of a squared plus b squared. So 3 squared plus 3 squared, 9 plus 9, 18. Which equals 4.2 meters per second. In our direction, combine the two, northeast. All right, which ball hits the ground first and why? So we have one ball getting dropped and one ball getting thrown out with a horizontal velocity. Now, if they're dropped at the same time from the same height, remember, they will hit at the same time. This is because the acceleration of gravity affects them equally. All right. Label each vector below the direction it is pointing. So this one's going north and west, so northwest. This one's going northeast. Remember, in case you don't know, compass. This one's going west. This one's going south. All right, be able to distinguish between each of these terms, and not just these terms. Make sure you're familiar with all your vocabulary that we did in the charts. Remember that your vocabulary will be due on the day of the test, so make sure it's ready to turn in. So remember, our trajectory is the path our projectile takes. Our projectile is our object launched or thrown. Sorry about my spelling. Our object that we've launched. Our launch angle is the angle at which it is launched. Remember, a 45 degrees will give us the furthest distance. All right, 90 degrees will not get you any unless you're trying to shoot a rocket into space. So we don't want 90 degrees unless you're NASA. The range is the distance that the projectile travels. All right, remember to study your notes as well as the study guide. We have the Kia posted in Edmodo for you. We have the Quizlet. Keep in mind some of the things we've already talked about, like we have several factors that affect projectile motion. Remember, it's not just launch angle. We had a couple other factors too that you might want to look over. Just make sure you do not rely solely on the study guide. Make sure you study your notes. Practice that Kia. Make sure you're familiar with their vocabulary words. If you have any questions, feel free to message me on Remind or in Edmodo. But remember, if you use Remind, I'm going to get that message sooner than I will with Edmodo. All right, have a good one, and I hope you do well on the test.